Previously we talked about the displacement time graph. So let's continue about displacement time graph. So let's draw a displacement time graph. Here is a displacement time graph, and we will do a case study or a case scenario for this graph. For example, a car started from rest is 0 distance, and it traveled a distance of 20 miles in some time. Then it stopped at uh, a fuel station. Then again it traveled 20 miles, and then again at 20 miles distance. So on the distance time graph we can write it like this distance. This distance is 20. This distance is 20. This distance is 40. This is the total distance, and this is 60. So the time taken to travel first 20 is 1 hour. Then it rested for 40 minutes. Then again, the next distance it covered in 20 minutes. So this makes it 2 hours. And then finally it reached 60 in 4 hours. So in this case, if I want to make a velocity time graph for this, we are going to like spend some time. This is an important topic, so we are going to spend some time on these graphs. So for example, this we want to calculate, or we want to find out the speed for at this region. Let's just say this a straight line is for constant speed. So because we can write it like this: the speed is constant in a straight line. The speed is constant in a straight line of distance time graph. So the speed is uh, there is some speed. We will calculate it later that how much that is. There is some speed at 1 hour. Then the car stops, so the speed becomes zero. Then after some times it again starts and moves with a constant speed. So the speed in this region is greater than, because it covers the same amount of distance in just 20 minutes. So the speed is 3 times greater. So we are going like this would be the speed in the next 20 minutes. And finally, the speed gets decreased in the last 2 hours. So this would be the speed in the last 2 hours. So the velocity time graph would be something like this. Let's just calculate the speeds, how we can calculate the speeds, and how are how like how we can study the distance time graph and velocity time graph in an easier way. So if you want to, by using this uh, graph, if you want to find the speed, the velocity by using this displacement time graph, what we can do is the displacement, or the velocity is equal to displacement divided by time. So in this case, the velocity would be as the distance covered in the first part. The distance covered is 20, and it is covered in 1 hour. So that would be equal to 20 miles per hour. 20 divided by 1 is equal to 20. So this would be equal to 20 miles per hour. In the second region, in this region, the same amount of distance is covered in the 20 minutes. So the velocity is equal to displacement is 20 miles and divided by as it is covered in 20 minutes. So if we convert 20 into hours, so that would be equal to 20 divided by 60. So this would convert the 20 into hours, 20 minutes into hours. So that would be equal to velocity would be equal to 60 miles per hour in this portion. And for the final portion, the displacement is same, that is 20 miles. The time is time from time for this region is 2 hours. That would be equal to 10 miles per hour. So now we have calculated the speeds. So we can mark this graph. So in this phase, in the initial phase, the speed is, as we have calculated here, the speed is 20. So this position is 20. At the second region, the speed is 0 because there is no distance covered. So the speed is 0 here. Speed is 60 here, and the speed reduces the velocity reduces to 10 in the final region. So this is how we can calculate the velocities by using a distance time graph. So we are going to like spend some time on this topic because this is an important topic for physics student, that you should know about the velocity time graphs or speed time graphs. There there are like a speed time graph in can be linear like this, or it can be like this. This means the speed is initially increasing, sorry, or it can be like this. Like we are going to discuss all of these three scenarios. That what is the difference between this? Let's call this A. Let's call this B, and this C. So in the first case, that is A, uh, speed is constant or the distance is increasing linearly. So that means the speed is constant. And like if a car is moving with with a velocity of 10 miles per hour, it would be covering a constant amount of distance every minute. Like if a car is moving with a constant speed of 10 miles per hour, it would cover a distance of 10 miles in every hour. So if it keeps on moving with the velocity of 10 miles per hour, so in 10 hours it would cover a distance of 100. So if if the graph of distance, or sorry, displacement and time is linear, like as shown in the A, so the velocity in this case is constant. But in the B, as we can see that initially the distance covered per unit time was smaller. Like initially, after some time passed, the distance is smaller with the same amount of time. With the same amount of time, like at this time, after, let's say this time is 1 hour. So in A case, or for the car A, it covered more distance at the same time, but the car B, it covered less distance. So that means initially the car started with a less velocity, but as time passed, it gained some velocity. And at time t, at this time, let's say this is 2.5 hours. Right after 2.5 hours, it covered the same amount of distance as the car A. So the trend B is a case of increasing velocity. So trend A is equal to constant velocity, Trend B is increasing velocity and trend C is decreasing velocity. So what does that mean? Because at the same time, uh, initially the car C, it covered more distance than the other two cars, but initially the velocity was greater, but eventually the velocity it reduced, and at after 2.5 hours, that is all of the three cars they covered the same distance. Let's call that distance 20 miles. So initially, if we want to plot the graphs of velocity for all of these cases, it would be something like this. The velocity time graph for these three cases. For car A, it would be like this, or this would be car for car A. For car B, it would be like this, like increasing velocity, and for car C, would be like this. So this would be the graph for car A. This would be the graph for car B. This would be the graph for car C. So I know that it is a little difficult for now to understand, but in the next lecture I will give some more time to this portion, the physics portion, so that I can like that you can understand these graphs better. So that's it for today. I don't want to saturate you further. So I'll see you tomorrow.